Okay, so let's try this without going to the graphing calculator and kind of go backwards from what we were just doing. Um, Given a graph, what are the answers? And then we're going to take that and do a little bit more with it too. But just think about how we look at the graph and think about where the solutions are or the zeros are. So remember, solutions and zeros are the same things as x-intercepts. So we want to make sure um, that just want you guys to have those terms all connected to each other. So if we look at this first function over here, this first graph over here, and think about where are the x-intercepts. So I've kind of got that labeled for you. It's at -6, -2, and 5. So that means that x is equal to all of those things as far as its solutions. So that's pretty easy. If we look at the next one, we have -8, -1, and 5 are the x-intercepts that I labeled there for you. So that's -8, -1, and 5. And if we look at the last one, we see that they have -3 and we have 4. Well, if you look at the shape of the graphs, they're all essentially the same shape. Like they're all n shapes, and so we know that n shapes come from x cubes. You would see that an x cubed gave us 3 solutions here, and an x cubed gave us 3 solutions here, but the x cubed is not giving us 3 solutions here. And so again, what's happening here is that we have this issue of this right here, this where the graph is just coming down and bouncing off the x-axis rather than passing through it like we see here at -8 or at -1 or 5, or even over here at 4, it's passing through the x-axis, not just hitting it and bouncing. So what's happening here, if we go back to example 2 really quick, we see where that happened also is that happened at the 0. Now what was special about that 0 compared to the other x values, right, -4 and -2? Well, it's because of this, that there was 2 zeros as answers. So that's causing this. So if we go back to our example here, what this is telling me by this bouncing like this is that there are actually 2 answers that are -3. Okay? So that's what's going to cause the graph to bounce off or merely touch the x-axis versus crossing it, is that when there is what's called a double root. And so here we're going to use that term root. Well, that's not spelled double. So we have solutions, we have zeros, we have x-intercepts, and then we have roots. Those 4 terms are all connected. And so when we have a double root or a root that shows up twice, a 0 that shows up twice, the graph will bounce at that point. And I like to use that term bounce. It's not a technical term, but I think it looks pretty spot on. As far as the way it describes what we see. So that's why that happens mathematically, is because of this x value showing up twice. The next thing I wanted to kind of do with these problems is to think about how would we write the equations for these problems. So kind of furthering this idea of undoing what we were just doing, using the picture to find the answers, and once we have the answers, to write the problem where the answers came from. So what we're going to do now is write the equation in factored form. And so I want you to take a step back again and think about where these numbers came from before. And so these numbers came from our factors. So we're going to write our answer in factored form. It's going to look like this. So here's the factored form of this equation. X plus 1 times x minus 1 times x minus 3. Well, where did -1 come from? It came from the x plus 1. All right, where did positive 1 come from? It came from the x minus 1. And where did positive 3 come from? it came from x minus 3. So we're constantly seeing that idea that there's a sign switch happening here. So if I think about where did negative 6 come from, that's going to come from an x plus 6. Where did negative 2 come from? It came from x plus 2. And where did positive 5 come from? It had come from x minus 5. Okay, so here's the factored form of the function that would give us this graph, or something very similar to it. Okay. Well, what about this function? What would its factored form look like? So g of x, I'll call it. So negative 8 would come from x plus 8. Negative 1 would come from x plus 1. And positive 5 would come from x minus 5. And last one here, I'll call it h of x. So where would negative 3 come from? It would come from x plus 3. Here, where would negative 4 come, or where did 4 come from? It would come from x minus 4. And then where would negative 3 come from? It would come from x plus 3. And the order you write these in doesn't matter. And if you felt like, since these two are the same, if you wanted to rewrite it as x plus 3 squared, and then x minus 4, you certainly could. Both of those answers are acceptable to me. So these are what's called the factored form of the functions that would give us these curves, or approximations of those curves. All right, that's it for example 3.